There is a famous riddle about light. What is made up of light but always remains dark? The answer is shadow. When light hits any object, they usually stop light rays from passing through, except glass. This creates shadow behind the particular object. It happens all the time. But what about the fire? Does fire have a shadow? Before we talk about the shadow, let's have a look at the fire. Fire has been one of the most common sources of light back in the past. It's bright and hot, so hot that we can use it to cook food. Fire is basically energy. We can see it and we can feel it. It emits heat and photons. There is a well-known chemical formula for fire. Hydrocarbons react with oxygen in the air and produce carbon dioxide, water, and energy. This is a straightforward equation, but this doesn't actually explain fire. Let's look at the candle. If you fire it up, wax starts melting and follows the previous equation. The blue fire you see here is the hottest part. It's more than 1400 degrees Celsius. When wax on the candle burns, the air surrounding gets warmer. The hot air becomes light-weighted and starts moving upwards. Gravity pulls down the cold air from the atmosphere and makes us see the blue flame. It's basically carbon dioxide burning at a high temperature. That's all good enough, but what about the orange color? Or the yellow part? Why are there two different colors? The answer of these particular questions leads us to Bohr's atomic model. Niels Bohr was a famous Danish physicist who won Nobel Prize in 1920 for the atomic structure and foundational contribution to quantum physics. He is mainly famous for his atomic model of a hydrogen atom, where he explained the color spectrum. This is a hydrogen atom. An electron is orbiting a photon, which is the nucleus in this case, at a certain distance. Niels Bohr said, when an electron receives enough energy, it jumps to a higher orbit, and when it loses energy, it jumps back to the lower orbit. This phenomenon was later confirmed. Now Bohr said that, while jumping off from the higher energy level, an electron emits some amount of energy. When the frequency of this emitted energy matches with the visible light frequency, we can see it. That's how every colored compound works. When a candle burns, hydrocarbons in the candle break down into carbon dioxide and water. Some carbon atoms form carbon dioxide and burn in lower parts. The electrons of carbon dioxide atoms jump back and forth and emit energy, which we see as the blue flame. The leftover atoms form tiny particles of soot. These eventually heat up and glow orange and yellow. It's the main part of the candle, the main source of light. That was all about fire. Now let's get back to our previous question. In order to create a shadow, an object needs to stop the light. When photon faces hindrance they can't travel through. That left us with the dark part without any photons. For fire, that's kinda impossible. Fire is the source of photon itself. Photons don't have any particular interaction within themselves. Unlike other particles, they barely show any interaction. They don't bounce off or stop each other. That's why when you flash a light against fire, photons from the flashlight and fire just pass through each other and don't interact. As they don't interact, we don't see any shadow.